We look first at some trigonometric relationships involving a right triangle. We define the sine of the angle theta to be the ratio of side A over B, or the opposite side over the hypotenuse. We define the cosine of the angle theta to be the side B, the adjacent side, over the hypotenuse. We define the tangent of the angle theta to be the opposite side over the adjacent, A over B. If we rewrite the first equation, we can write that A is equal to C times the sine of the angle theta. And if we rewrite the second equation, we can write that B is equal to C times the cosine of the angle theta. We can also make use of the Pythagorean theorem that the side C is equal to the square root of A squared plus B squared. We will frequently use these equations when working our vector problems, and it would be a good idea to write these on a 3x5 card to use them when solving the problems. Let's look now at some vectors. A common vector is displacement. An object that is displaced from one point to another can be represented by an arrow. The length of the arrow represents the magnitude of the vector. The direction of the arrow represents the direction of the vector. The vector can be broken down into components. Here we see the vector A broken down into two mutually perpendicular components, A sub x and A sub y. The value of A sub x is equal to A times the cosine of the angle theta 1 being the angle between the vector and the x-axis here. The A sub y is equal to A times the sine of that angle. If the object has a further displacement, this can be represented by another vector, which also can be broken into x and y components. In adding two such vectors, we draw an arrow from the tail of the first arrow to the head of the last arrow. The x component of that resultant vector is simply equal to the sum of the x components of the individual vectors, and the y component of the resultant vector is equal to the sum of the y components of the individual vectors. The magnitude or length of the resultant vector can be found from the Pythagorean theorem, and the angle that the resultant vector makes with the x-axis can be found from the fact that the tangent of that angle is equal to the ratio of the y component of the resultant vector to the x component of the resultant vector. Let's use these ideas now in our first problem.